Welcome to our video where Juhi, Meso, Emma, and Mia will show you how to perform a titration experiment.
We perform titrations to determine the exact concentration of an analyte by reacting it with a titrant until the reaction reaches its equivalence point. The balanced chemical equation shows how NaOH reacts with our acid, potassium hydrogen phthalate, or KHP, in a 1-to-1 ratio.
To determine our unknown concentration of the NaOH solution, we must weigh out some KHP. Here, we're using 0.05 grams of KHP. Convert that to moles using its molar mass, and then convert moles of KHP to moles of NaOH using the 1-to-1 ratio between the two.
The analyte is the solution with an unknown concentration. The titrant is the solution with a known concentration, and the equivalence point is the exact moment when the acid and bases have completely reacted in equal amounts. Knowing these terms helps us understand how to find the precise concentration of our unknown solution. We'll also detect the endpoint of the reaction using our indicator, phenolphthalein, which changes from colorless to light pink when the titration is complete. Phenolphthalein is a pH indicator that shows when the solution changes from acidic to slightly basic.
Before filling the burette, we prime it with the titrant, meaning we rinse the inside with a small amount of the same solution that we'll be using for the experiment. This step removes any leftover water or impurities that could dilute the titrant and affect our results. Once the burette is fully coated with the correct solution, we can fill it confidently knowing that every drop delivered during the titration has the proper concentration. Priming the burette ensures consistency within our final measurements.
Remember that molarity is measured as moles divided by volume in liters. Now that we have the moles of NaOH, we need to complete our titration to find the liters of NaOH delivered.
We record to 1 degree of uncertainty to provide a reliable range of possible value and increase validity of the data by accounting for systematic or human error.
As NaOH is added from the burette into the KHP solution, the two react to neutralize each other. Throughout the titration, we swirl the flask to ensure thorough mixing. As we approach the endpoint, the color starts to fade from colorless to a faint, light pink. The light pink color that stays for about 30 seconds indicates that the titration has reached the equivalence point, meaning the acid and base have completely reacted. Once we reach the endpoint, we record the final burette reading to 2 decimal places. The volume of NaOH is found by subtracting the initial volume from the final volume. This tells us exactly how much titrant was used to neutralize the acid. When recording measurements, we read the meniscus, the curved surface of the liquid, at eye level. All burette readings should be recorded to 1 degree of uncertainty, meaning we estimate 1 extra digit beyond what the scale shows. This makes our data as precise and consistent as possible.